Hey guys, welcome back. We're going to start topic 7, and topic 7 is all about similarity. And then in this first lesson of topic 7, we're going to start by talking about dilations. So we have two objectives. We're going to dilate figures on coordinate grids and off coordinate grids, and then understand how distance and lengths in dilations are related to the scale factor and center of a dilation. So we have a couple new vocabulary. The first one is dilation, right? And then the second one is scale factor. So we're going to go to the very end of our topic 7 notes, and we're going to find our terms page, and we're going to review what these two terms mean. Okay, so here's our terms page, and the first thing that we're going to look at is a dilation. What is a dilation? So something that maybe you've heard before is when your pupils dilate. Sometimes if you go to the eye doctor, or if you look at a bright light or things like that, your pupils will dilate, right? They will either get really big or really small. And so what a dilation is, it's a transformation that preserves the shape but not the size. So when your pupils dilate, they're still circular, right? They were circular, they're still circular, they're just bigger or smaller. And so what happens is the shape stays exactly the same, whatever the shape is, stays exactly the same, it just gets bigger or smaller. So like here, right, this black shape is my original, and it has dilated, it has gotten bigger, and so now it is bigger here, okay? The center of dilation is the fixed center, so the point that you're dilating about. And then here, the scale factor. So how do you know how much bigger? Has the shape doubled in size? Has it tripled in size? Do you multiply by 10, right? did it shrink? Did it shrink by half? So to find the scale factor is just the ratio of what you multiply by to get from the original shape to the new shape. And so how we find this is we take the new side, so a length of the new side, and we divide it by the length of the corresponding original side. Right? So like if I knew the length of xy was 2, and then I knew the length of x prime, y prime was 4, then I could, do 4 divided by 2, which is 2. So I know that I multiply these sides by 2. Okay? So it just allows us to find what is it that we are multiplying by to go from one shape to the other. That's it for our terms. And so we're going to go back to 7.1 here, and we're going to look at some examples and see how we can use this. Okay, so let's look at example 1 here. It says rectangle ABCD is a dilation with center P of A prime, B prime, C prime, D prime is a dilation with center from the triangle ABCD. So we know that ABCD is the original, and then A prime, B prime, C prime, D prime is the dilated figure because of those primes, right? Remember that the prime value is always the one that we've done something to. So it says, how are the side lengths and angle measures related? Well, looking, they're both rectangles, right? Because the shape stays the same. So in a dilation, the shape stays the same. So if A prime, B prime, C prime, D prime is a rectangle, then A, B, C, D is also a rectangle. So that means the angle measures, the angles are going to be congruent. Those are the same. The side lengths are not going to be congruent. Okay, so in order to find what my ratio is, right, I do the new side divided by my original side. So that means I can take, let's just look at this bottom one. The new side would be A prime, D prime. The original side would be AD. So what's the length of A prime D prime? So it's 1, 2, 3, 4, 5, 6 over, and then AD is 2. So I get 3. Okay. And then we could check again with one more, right? So A prime to B prime over AB. If I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3, 9 over 3, which is 3. And if I did it with all 4 sides, I should get 3 every single time. That means that I have taken my original shape and multiplied the sides by 3. So we can say that the ratio of side lengths is 3. So I can multiply all of my original sides by 3 and it'll get me the new shape. Okay. So moving on to the next one, we have a try it. It says rectangle W prime, X prime, Y prime, Z prime is a dilation with center P of W, X, Y, Z. So again, here is my original shape. Here is my new shape. How are the side lengths and angle measures related? So go ahead and try this one. Use the same exact thing that we did up above. And so pause the video, try it, and then when you're ready to go over it, hit play. Okay, so hopefully you guys tried this. The first thing I see is that they're both rectangles, so the angle measures are the same, right? That will always be the case. Dilations never change angle measures, okay? So the angles are always going to be congruent when we're looking at a dilation. So then I just need to know the side lengths, right? Or what is the ratio of sides? So let's pick a side. Let's do xy and x prime, y prime. So the new side is x prime, y prime. The original side is xy. So the length of x prime, y prime is 2. And the length of xy is 1, 2, 3, 4, 5, 6. So 6. So I get 1/3. And let's do another one. Let's do x prime, w prime over xw. So x prime, w prime is 1, and then xw is 1, 2, 3. And again, if I do this for all 4 sides, I will get 1/3 every time. So the ratio of side lengths is 1/3. Okay, so always when we're doing dilations, always are you going to have angle measures be the same. Okay, then to find the ratio of the side lengths, you just do, right, the new side over the original side. So let's look at example 2, which is very, very similar. It's here I have quadrilateral JKLM and then also the prime. It says, what is the scale factor? Okay, remember the scale factor is always new over original. And so I know what's new because of the prime. So my new side is 18 over my original side, which is 12. And if I simplify that, I get 3/2. So 3/2 is the scale factor. That's it. So we have a try it here. First part says, is the dilation an enlargement or a reduction? Meaning, did the shape get bigger or did the shape get smaller? And then part B says, what is the scale factor? So you use your new over your original to find the scale factor. So go ahead and hit pause on the video, try it, and then when you're ready to go over it, hit play and we'll go over it. Okay, so hopefully you guys gave this a shot. Let's look. Is the dilation an enlargement or a reduction? ABC is my original, and A prime, B prime, C prime is my new shape. So did it get smaller or did it get bigger? Right? It got smaller. So it's a reduction. because you should always explain your thinking. A prime, B prime, C prime is smaller than ABC. Okay. And then part B says, what is the scale factor? So I'm gonna, do my new over original. I really only need to do it once, but you can do it more than once and it's no problem. So I'm just gonna do B prime, A prime over BA. So the length of B prime, A prime is 1. The length of BA is 2. It doesn't reduce, so the scale factor is 1/2. You can do it more than once, right? If I did C prime, A prime, I would have 2 over C to A is 1, 2, 3, 4, 2 over 4, which is also 1/2. So I can do it more than once, you just don't necessarily have to. Okay, hopefully this makes sense. We're gonna kind of switch gears and look at some real world problems now and kind of see like how do we use this. Okay, so let's look at example 3. It says a blueprint for a new library uses a scale factor of 1 over 50. So this means 1 square is 50 inches. Centimeters, right? These are in centimeters. Centimeters. Okay, so 1 square is 50 centimeters. So Mr. Ayer measures the readings based on the blueprint to find the actual dimensions and area so he can order the furniture. Okay, what are the actual dimensions of the reading space? So let's look at the length first. And it doesn't matter, you could do the width first. So here I have 14 centimeters, right? And I don't know what that equates to, but I do know that the scale factor is 1 over 50. Okay, so 50 squares is 1 centimeter, quote unquote. So I'm just going to cross multiply and solve, right? So I have 1x equals 14 times 50 is 700. Remember that this is in centimeters. When was the last time that you're like, oh, I think the height of that wall is 200 inches, right? We don't really use inches to measure big spaces like this. And so what's more appropriate, right, is like we tend to use feet or meters. And so saying that something is 700 centimeters is a really weird way to say this. So what we would do is we would just transfer this to meters, and there's 100 centimeters in 1 meter. So this is actually 7 meters. So the length is 7 meters. Okay. And then my width here, it looks like it has 12. So I have 12 over x. Oh, let's not use x because we already did, right? Let's use y instead. So 12 over y, and the scale factor is 1 over 50. Cross multiply, and I get y is equal to 600 centimeters. Again, that's like a super weird way to say it. So we want to change that to meters. So we're going to say 6 meters. That makes a lot more sense in terms of measuring a room. Okay, then part B says, what is the actual area of the reading space? Well, if we remember, area is equal to base times height, area of a rectangle. So it's 7 meters times 6 meters. So the area is equal to 42 meters square. And there we go. 42 meters squared. Okay. Next one, we have a try it. Very similar. There's a blueprint for a house uses a scale of 1 to 20. Okay. If the dimensions of the actual kitchen are 3.1 meters by 3.4 meters, what are the dimensions on the blueprint? So now we have the dimensions of the actual kitchen, not the blueprint. So when we up here on this on the previous problem, right, we knew the blueprint was 14, but we didn't know the actual dimension of the room, right? And that's how we got this. But here, right, this is the blueprint, and then this was the actual. But now here it's switched. I know that the actual kitchen is 3.1 by 3.4. What are the dimensions of the kitchen on the blueprint? So we're just gonna have to switch it, okay? So go ahead and see if you can do part A, and then so pause the video, and then let's just go over part A when you're ready. Okay, so let's look. Here, I don't know what the blueprint length is, but I do know that in real life it's 3.1 meters. And I do know that this scale is 1 to 20. So I cross multiply, and I get 20x equals 3.1. Divide by 20, and I get 0.155 meters, which is weird, right? We can also say 15.5 centimeters. Might just move that decimal place over twice. Again, when we're talking about something small, I wouldn't say, oh, that's like a third of a foot, right? We would say that's 4 inches. So just knowing kind of when to use what language. And then for the width of this, again, I don't want to use y, or I don't want to use x, I mean. So let's do, I don't know what the blueprint is, but I know that the actual kitchen is 3.4. And I know that the scale factor is 1 to 20. So again, I'm going to solve. We get 20y is equal to 3.4. Divide by 20. And y is equal to 0.17 meters. Again, kind of a weird way to say it. So if I move that decimal place over twice, it's the same thing as 17 centimeters. Okay, so that is the dimensions of the kitchen on the blueprint, right? One length is 15.5 centimeters, the other one is 17 centimeters. And then part B says, what is the relationship between the area of the actual kitchen and the area of the kitchen on the blueprint? So let's look. Let's find the area of the actual kitchen, right? So area is equal to base times height, so 3.1 times 3.4 meters. So the area of the actual kitchen is like 10.54 meters squared. Okay, now let's look at the blueprint. Here, so on the kitchen we used meters. On the blueprint, we're going to want to also use meters, okay? And let's make a little note of this. We want the same units so we can compare the two. Right? If one of my dimensions is in meters and the other one's in centimeters, it's really hard for me to compare. So I want both of them in meters so I can compare. Okay, if I say like, oh, this one is 12.2 feet, and then I say this one is 375 inches, I don't have any way of comparing that, like which one's longer. I don't know, right? So that's why we want to use the same unit. So we're going to use this 0.155 meters times 0.17 meters. We want to keep it in meters. So the area on the blueprint My dog's freaked out, sorry. So the area here is 0.02635 meters squared. Okay, so now at least they're both in meters squared, so I can compare them, right? So if I take the actual kitchen, which is 10.54 meters squared, and I divide it by the blueprint kitchen, which is 0.02635 meters squared, I get about 400. Okay, so this means that the kitchen, the actual kitchen, is 400 times larger than the blueprint. So that's how it can compare, right? The actual kitchen is 400 times larger than the blueprints. Okay, one last problem for you guys to try using the same idea here. It says Yama used 1/4-inch grid paper to make a plan of his apartment using a scale factor of 1/96. What are the dimensions of his apartment? Okay, so we know that each one of these little grids is 1/4 of an inch. So if I want to measure like the length, right? This is 1/4 of an inch, 1/2 an inch, 3/4. So this is 1 inch. And then 1, 2, 3, 4. This is 2 inches. 1, 2, 3, 4. This is 3 inches. So the blueprint is 3.5 inches by 1, 2, 3. So here's 1 inch. 1, 2, 3, 4. 2 inches. 2 inches. Okay, so knowing that the grid was 1/4 grid, right, allowed me to figure out the dimensions of the blueprint. Now it says, what are the dimensions of his apartment? So go ahead and hit pause on the video, see if you can find the dimensions of the apartment, and then when you're ready to go over it, hit play. Okay, so hopefully you gave this a shot. Let's start with saying, okay, I know that the blueprint is 3.5 inches. I have no idea how many, inches the actual apartment is, so that's X. But I do know that the scale factor is 1/96. So I can cross multiply. 1 times X is X. 3.5 inches times 96 is 192 inches. Again, that's a weird thing to say, right? Oh, the length of my room is 192 inches. So I can divide this by 12 to get feet, and I get 16 feet. So the length of his apartment is 16 feet. Now let's look at the width. I know that the blueprint is 2 inches. I don't know how many inches the apartment is, but I do know that the scale factor is 1/96. So again, I can cross multiply, which gets me X is equal to 2 times 1, sorry, oh my goodness gracious, you guys, I am a wreck. And you're probably like, this lady's crazy, right? 3.5 times 96 is definitely 336. And then divide that by 12 is 28. There we go. 2 times 96 is 192 inches. Again, weird measurement. So if I divide that by 12, I get 16 feet. So his apartment is 16 feet by 28 feet. And that's it. So that's it, you guys, for 7-1. You have some practice of it. Make sure that you reach out if you have any questions. And good luck. We'll see you soon.